think that what's interesting in talking about the other schools, other universities, we're not alone in approaching artificial intelligence, but how different we are taking our approach. And from an engineering school, from an engineering school that focuses on the in-betweens, on the interdisciplinary efforts of problem
Yeah.
solving, because we don't believe one discipline solves any particular problem well. It's about how they work together. And to your point, Gaurav, and I think we should probably unpack this a little bit more. We distinctly do not see artificial intelligence as a subset of computer science. We do not see it as a specialization or an emphasis. Although students can study computer science still, they can still take artificial intelligence coursework. We're not
Yeah.
taking that
Yeah.
away, and that still
Yeah.
has value. But can we talk about that distinct decision?
Very much so, very much so. So it's certainly possible to get a computer science degree here at USC. We have one of the top computer science offerings in the US, indeed across the world in many ways. And a student who elects to get a bachelor's degree in computer science at USC can develop a strong foundation in many aspects of AI. But they will largely be the statistical foundations of AI and in the software aspects of AI. If a student desires to be a true, what I would call a full stack AI engineer, where aspects of the design of chips and circuits and is as important as designing the software that's built on top of them, then I would look, if I was that student, I would look to our new AI degree because it
Mm.
really aims to give students that entire bottom to top AI stack development expertise. Um, it also expands students laterally. So Eric alluded to the fact that a good modern AI engineer is also a good modern data engineer. And so if you want to be a data engineer who can attack problems in biomedical sciences and engineering and civil engineering, supply chains, medicine, business, if you want to be the kind of data engineer who can do that, then the AI techniques that go into that are also important to learn ground up, not as quote unquote mere applications. And so, what we're trying to do with this degree is to give students a certain amount of breadth across all aspects of data engineering while giving them almost unprecedented depth in the entire AI stack so they can understand how AI systems are built from the hardware all the way up to, say, ChatGPT.
Right.
How do you see the entire stack? And that's why we really realize that you can't do this as part of a computer science degree. You can't do this as part of a electrical engineering degree. You really can't do this as part of a systems degree. You really need a degree of its own. So you can be a great AI engineer on some focused areas of AI by studying computer science or other disciplines. But if you want to be an AI engineer and nothing but an AI engineer, then then our degree, I think, is the
Yeah.
game in town.
I think you're right, and I think just from to we view this from a lot of our listeners' standpoint, which is, I'm in high school or I'm a parent of a high school student, and to be honest, there's a lot of fear in the world about I want my kid to be successful. The student saying I want to be successful. I'm going into a world that is unknown. I'm looking at engineering degrees, and one of them just wants to clear that what's the best one, and we know that they need to find the right one that's for them. But how do we talk about this idea of looking at this broad spectrum of academic programs that we're offering, someone that's thinking about buildings and infrastructure from civil engineering perspective to, well, I hear that the world is headed towards AI, so should I study AI? And I mean, Eric, maybe you could talk about this if we have that distinct example of someone that's really fascinated by infrastructure, but is pressured to believe that AI is the world. How would they go about this? And knowing that, both are valid options, we just need to help them understand that.
Both are obviously very important. Yeah. And part of this is a question of depth, right?
Yeah.
Uh, it's a civil engineering degree, for example, is going to learn all the mechanics of how buildings are built and made safe, understanding the forces in them, understanding the kinds of loads and requirements that are necessary. But our civil engineering program also has several courses that teach students a little bit about introductory programming and then data analysis, probability, and some courses that dig into machine learning as well, which is part of AI,
Yeah.
to give them some exposure to those areas, and as well as several of our Viterbi-wide courses also bring some introduction to AI, machine learning, data science, and so forth as well. The engineer of the future, regardless of which program they pursue, needs to have some familiarity with AI because it is changing every single field.
Yeah.
The difference here, of course, with the BSAI degree is it is then, as Gaurav said, sort of full stack from top to bottom, focused on AI. That said, the AI engineer isn't going to know how a building shakes during an earthquake, and so
Right.
we do need students that graduate and go on into industry that have this sort of spectrum of different expertise, but with the ability to be able to talk, at least have some language in common
Right.
across the different disciplines.
This might be to some people, and I'll see if I can formulate my question mid thought, but sometimes we have high school students and families that are looking at disciplines, and they tend to think of this as a concrete pipeline to an end result. And so in some situations, it's a simplified version of I'm going to study aerospace engineering because then I will work at, quote, an aerospace engineering firm, or I'm going to study astronautical engineering to work at SpaceX. And I guess I'm coming around to this idea of like, sometimes I talk about SpaceX. SpaceX hires astronautical engineers, aerospace engineers, mechanical engineers, electrical engineers, computer scientists, industrial systems engineers. How do we help students understand where an AI engineer fits in? Because I'm fairly certain the answer is an AI engineer is going to be hired by everyone.
Everywhere.
And it's going to be a whole new discipline.
That's exactly right. That's
And
exactly right.
Yeah, and it's AI is being used in every single discipline and growing.
Yeah.
Everything from drug discovery to business development to I was talking to one of our faculty recently who's using AI to do sign language to text, sign language to speech, and vice versa to help people who have hearing challenges. I mean, AI is developing across virtually every single field.
Right.
And so, yes, I think the AI engineers are going to be hired by aerospace companies. They're going to be hired by businesses. They're going to be hired by civil engineering firms. They're going to be hired by people who make machines that make corrugated cardboard. I mean, everything across the board.
How do we help people understand that this is not a degree in how to use ChatGPT?
I think it's a good question. I think it's important to remember that all our degrees, AI, our newest AI offering is no different. But none of our degrees really are about using turnkey pieces of software or turnkey pieces, turnkey methods. They familiarize students with all modern technologies and methods, but most importantly, they lay the foundation so our graduates have the ability to engage with the next thing when it comes along in a superior way.
Yeah.
Because we aim with our bachelor's degrees to lay the foundation for a lifetime. And the new AI degree is no different. It's exactly like our civil engineering degree or a computer science degree. It isn't about the software of the moment. It isn't about the building codes of today. It is about how to think about the principles that underlie these artifacts, and therefore to reason and invent about the new artifacts of tomorrow. And our graduates have been supremely good at that in the other disciplines. And we are committed to making sure that that's what our graduates will get when they graduate as AI engineers. So the tools of today will firmly be within their hands. But we would be failing in our duty if we sent out graduates with just the tools of today in their hands. What we send them out with is a firm grasp of those tools, but an even firmer grasp, if you will, of the principles underlying them. And where is the greenfield opportunity? Where is the future to be invented? And our graduates tend to then go there. So they're adept at doing the work of today, but they're also adept at inventing tomorrow.